Hello everyone, this is Mr. Fawcett back for part 2 of our solving one variable equations lesson. We're going to jump right in. We are down at our first fraction equation. Okay, and remember, you're doing two things here. You're solving it in the left-hand column algebraically, and you're writing out each step in the right-hand column. So take some time to try these on your own before you listen to the explanations and look at the solutions. Once you've taken your time to try these out, then come back and check your work against mine. Okay, so for the first problem, we are given an equation with two fractions, and we want to be able to combine our two x terms so that we just have one x. The problem is we can't add fractions that don't have the same denominator. So there's a couple different ways you can simplify the two fractions. The way I'm going to show you is just to find a common denominator and add them together. So I'm going to use a common denominator of 15, which means I'm going to multiply this fraction by 3 over 3, and I'm going to multiply this fraction by 5 over 5. So what that's going to give me is 12/15 x plus 5/15 x equals 50. Now I can add the two fractions together. I get 17/15 x is equal to 50. So again, a couple things you can do here. I think the easiest thing to do is get rid of the fraction all at once. So to do that, you can multiply by the reciprocal. So I'm going to multiply by 15/17 to both sides. And the nice thing is that on the left, these fractions simplify to 1, so I'm left with x. And then if you have access to a calculator, you can punch it in now, or you can try to simplify on your own. This is going to give you 750/17. If it doesn't say to round, and you can't simplify your fraction any further, which we can't, we are going to leave it as 750 over 17. It may look a little weird, but again, the higher level your math course is, the less you're going to be given problems that come out nice and neat, because that's generally just not how the real world works. Not every solution to every problem is a nice, neat natural number or a nice, neat integer. If they did say to round, then you would have to look at what decimal place they want you to round to, etc. But because they don't, we're just going to leave it as the exact answer, which is our fraction. Okay, now we're going to write out our steps. All right, so our first step was to find that common denominator. Second step was to add the two fractions together once they did have the common denominator, which would also be, you could call that combining like terms. Number 3 was then to multiply both sides by 15 over 17, and that was to simplify the fraction next to our x. And finally, we need to think about whether or not we can simplify our answer. In this case, we couldn't, so we would just leave it, but there may be some times where the numerator and denominator share a common factor. Okay, let's move on to the next problem. So we have another problem that involves a fraction, which is good. Sometimes we tend to shy away from fractions, but again, they're going to pop up in many equations that you have to solve from this point forward. This one's a little different. The fraction, the x's are not on the same side. So we don't necessarily need to find a common denominator because we only have one fraction here. What we want to do is try to get rid of the fraction. So is there a way to get rid of the denominator or simplify the 3 that's in the denominator? And to do that, we're just going to multiply both sides by 3. Now it is very important that you put parentheses around your right-hand side because you are multiplying the entire side by 3, not just the first or the second term. Once that happens, I end up getting x plus 7. I need to distribute this 3. Is equal to 3x minus 12. I'm going to move my x to the other side by subtracting it. So I get 7 is equal to 2x minus 12. Let's add 12 to both sides. So I get 19 is equal to 2x. Divide by 2, and I get 9.5 is equal to x. You could also leave this as 19 halves. That's a simplified fraction, so that is acceptable. Because this decimal terminates, the decimal is an exact answer, so that it would be acceptable too. If you'd have to round to put it in decimal form, then you should probably just leave it in fraction form unless they specifically say to round to a certain value. Okay, let's now write out our steps. All right, so step number 1 was to multiply both sides by 3 and make sure that you distributed on the right-hand side. Step number 2 was to subtract x from both sides to get the x's on the same side. Step 3 was to add 12 to both sides. Step 4 was to divide both sides by 2. And then step 5 was to see if you could simplify the fraction. But 19 over 2 or 19 halves does not simplify. So you can either write it as a decimal because it terminates, or you can keep it as a fraction. Just a point worth making. You may be writing your steps out slightly differently, right? You could have done your algebraic steps in some different orders, which is okay, as long as the math is logically sound. You could also describe your steps in different ways. But the idea here is just to get you in the practice of explaining your work. So the same work can be explained sometimes several different ways. We have some different vocab words that mean the same thing. But the idea is that you are explaining it in one way or another. And as we move through the course, we'll talk about which vocab is best, and some words are more informal, some words are more formal and better used in a math classroom. But again, the point of today's lesson is just for you to focus on getting the explanation out there, and then we'll continue to refine it as we move through this course. Okay, on to the next one. So I actually think that this one was one of the easier ones, even though I put it a little later in the queue of questions. But the first thing I'm going to do is I'm going to subtract 3x from both sides to get our x terms on the same side. That's going to give me 8x minus 9 is equal to 15. I'm then going to add 9 to both sides. It's going to give me 8x is equal to 24. And then I'm going to divide both sides by 8 to get x is equal to 3. All right, let's go ahead and write our steps. So again, our first step was to subtract 3x from both sides. Second step was add 9 to both sides. Then our third and final step was divide both sides by 8. So pretty straightforward one. Let's take a look at what we have next. All right, good. So this one we have a radical symbol. Again, maybe a type of equation you got to in Algebra 1, maybe you didn't. But there's just a different type of inverse operation that we probably haven't used as often in our mathematical careers up to this point. So the first thing you want to do is you want to try to isolate the radical. So if I can divide both sides by 5 here, which is going to give me the square root of 2x equals 8. Now, when the radical's by itself, the inverse operation of square rooting something is going to be to square it. And we sort of talked about that with the first problem. We were just going the other way, right? We had this problem, x squared equals 36, and we said the inverse operation of squaring was square rooting. Well, if they're inverse operations, over here we just have a square root, so we're going to do the inverse and square it. And I am going to square both sides. That is going to give me 2x is equal to 8 squared is 64. And my final step is just to divide both sides by 2, and I get x is equal to 32. So you're not going to see a ton of complicated equations with radicals in them in geometry, but you do need to know what the inverse operation of square rooting something is. In this case, or in all cases rather, it's squaring the square root. Okay, let's put down our steps. All right, so step number 1 was to divide both sides by 5 to isolate the radical. Then we squared both sides to undo the radical or the square root symbol. And then we divided both sides by 2. Okay, that is the end of this section. So you'll see in the next set of problems, you have some practice problems. And I don't require you to write out the explanations for these, but you must show all of your work. We're not going to go through all of these. I'm going to pick a couple that are slightly different than the examples from above, because you can always use the above examples to help you solve these. I'm just going to choose ones that are slightly different and go through some of those explanations. But before you keep watching the video, pause it, attempt all these on your own, and then when you're ready to come back to the video and see how you did. Okay, so the first one we're going to start with is number 4. I think numbers 1 through 3 you'll be able to figure out, and if you can't, you can always go back to the problems we did up above to help you out. Number 4 is a little different because we have a fraction on both sides. Now, there's a couple different ways you can go about this. You can simplify these fractions as far as get rid of the denominators. You can do this in 1 step, or you can do it in 2 steps. Whenever you have a single fraction on either side of an equals sign, you can do what we call cross multiply. And this is just doing 2 multiplication steps in 1. Now, what you're doing is you're multiplying what's inside each of our bubbles. So I have 3 times the quantity q plus 1 on one side, and on the other side I have 2 times the quantity q minus 1. Okay, so this is one way you can do it, and we'll go from here. I'm now going to distribute. I'm going to draw my arrows. I'm going to get 3q plus 3 equals 2q minus 1. I'm going to subtract 2q from both sides. It's going to give me q plus 3 equals negative 1. Then I'm going to subtract 3 from both sides, and that's going to give me q is equal to negative 4. Okay, so that's one way to do it. I'm now going to quickly show you another way. So if you forget what cross multiplying is, if you forget how to do it, you can still solve this problem. You just need to choose which denominator to simplify first. I'm going to choose the one on the left. So I'm going to multiply both sides by 2. Okay, so that's going to simplify over here. So I'm going to get q plus 1 is equal to 2 times the quantity q minus 1 over 3. Okay? Now I'm going to multiply both sides by 3 to get rid of the denominator on the right. So these are going to simplify, and I'm left with 3 times the quantity q plus 1 equals 2 times the quantity q minus 1. And you'll notice that this equation right here is the same thing we got after cross multiplying. It just took us 2 steps, but we still got to the same place. So many times you're solving an equation, you can take different paths and still arrive at the correct answer. I'm not going to keep solving this because we just did that previously, and the work's going to be the same. Okay, let's see what we have next. The decimal equation, again, works the same way as an equation with integers. You're just working with decimals. Number 6, we've already done an example like that up above, so I am going to leave that to you. We are going to do 8. I think you all can do, actually we'll do 7 as well. That's a quick one. For number 7, first thing I'm going to do is divide both sides by 3. Again, I'm trying to get x by itself, so first thing is to divide out the 3. So I get x squared is equal to 108 divided by 3 is equal to 36. Then I'm going to square root both sides. And just remember that you're going to get two answers here. So you're going to get x is equal to plus or minus the square root of 36, which is equal to 6. Okay, number 8. This is a tougher one because you're going to have to do some factoring. So even though you could follow our example from up above, because this is probably one of the tougher ones, I'm going to go through another example. First thing we need to do is get the equation equal to 0. Or set it equal to 0. So I'm going to subtract 22 from both sides. So I'm going to have x squared plus 9x minus 22 is equal to 0. Now, I'm going to need to factor. So I'm eventually going to have something that looks like this. But I need to know what to put inside of my parentheses. So I'm going to create this factor sum chart. So factors, F stands for factors, S stands for sum. I'm looking for factors of negative 22 that sum or add to positive 9. So you can just think factors of negative 22, positive 1. That gives me a sum of negative 21. I can do negative 11 and positive 2. That gives me a sum of negative 9. So we should see, okay, if I do 11 and negative 2, that gives me a sum of positive 9. And that is the row that we want to look at. That's going to give me x plus 11 times the quantity x minus 2. Using the zero product property, we want to set both of these factors equal to 0, because if one of them is equal to 0, then it doesn't matter what we multiply, as the entire left-hand side will be equal to 0. So I have x plus 11 equals 0, and I have x minus 2 equals 0. And then I just solve each of these. So I get x is equal to negative 11, that's one solution, and add 2 to both sides over here, and x is equal to positive 2. That is my other solution. Again, you can pause the video, rewind, think about why I'm doing each step. You don't necessarily have to keep up at the speed that the video is going. Okay, so we come down here. Let's see. Let's do one more. Let's do number 12, and that'll take us to about 20 minutes. Okay, so number 12 has a radical, and like we mentioned in the radical problem up above, we need to get the radical by itself before we do any squaring to either side. So the first thing that I'm going to do is I'm going to subtract 10 from both sides. So I'm going to get negative 3 times the square root of x on the left is equal to 30. Right? These 10s simplify. Now I'm going to divide by negative 3 to get the radical, or the square root expression by itself. So I get the square root of x is equal to negative 10. Now, here's where we should stop and think for a second. If I take the square root of a number, will I ever get a negative number? And you can test it, right? If you may think, okay, maybe I need to take the square root of negative 100, right? But if you take the square root of negative 100, this is something that is non-existing. It does not exist. This answer, if you put it into your calculator, you're going to get an error. You cannot take the square root of a negative number. So for this problem, if you ever have a square root that is equal to a negative number, you can automatically say no solution. Right? This problem does not have at least a real number solution. So there will be a solution, but it's going to deal with imaginary and complex numbers, and that's not something you're going to even look at until Algebra 2. So for now, we are perfectly okay saying no solution because we are strictly talking about the real numbers, which is the number system that you all have worked with up until this point in your math career. Now you may think, well, wait a second, what if I kept going with my process? What if I squared both sides? Okay, well, if you keep going and you square both sides, you're going to get x is equal to negative 10 squared is 100. The problem is, if you substitute this back into your equation, the square root of 100 is positive 10. It's not negative 10. So if you had kept going and got an answer, it's always good to go back and check your answer and see if it makes sense. Go substitute it in, and you can actually just substitute it into your original equation and see if that equation is true. All right, so we just passed the 20-minute mark, so we're going to cut the video off here. Just because we didn't go over a problem on the video doesn't mean you shouldn't try that on your own. So try those other problems on your own. Come back to me if you then still have questions. This is Mr. Fawcett. As always, enjoy the rest of your day, and I look forward to seeing you next video.